Space travel, space use became prominent many years ago. And this thing is really 1970s and 1980s technology. But since it's the biggest thing in the room, it's kind of impossible to ignore it when you walk in here. This is a space shuttle. This is the Space Shuttle Discovery. This space shuttle went into space 39 times. It did more things in space than either of the other two space shuttles that are still around, but none of them are flying anymore. This one made its last mission in 2011, and in 2012 NASA gave it to us so that you could see a space shuttle that actually went into space. I said it went into space 39 times. And it probably did more different things than either of the other two existing space shuttles, one in Florida and one out in California, or the prototype that we used to have here that's now up in New York. It did many different things. It was a truck. It was designed to carry things that were possibly as big as 45 or 50 feet long and maybe 15 feet in diameter. The reason why it was built to carry big things into space is because President Nixon had decreed that there would be a single big delivery system into space, and that whatever NASA came up with had to accommodate whatever the military needed to take into space. And the military was building spy satellites that they wanted to put into space, called the Corona series of satellites that were 45 feet long and almost 15 feet in diameter. Well, at the same time, NASA was building a telescope, an optical telescope that was going to end up being 45 or 50 feet long and 15 feet in diameter. So the net result of those two needs, the military need for spy satellites and the NASA need for scientific satellites, resulted in NASA coming up with the concept of a space shuttle, a spacecraft that could take big things into space and then come back to Earth. Back in the back here, you can actually see some early models of what NASA was toying with as a possible candidate for doing that sort of thing. Maybe it could have jet engines on it, so that when it came back to Earth, we could land it anywhere. The problem with carrying jet engines with the shuttle into space meant you had to carry the engines and the fuel for the engines into space, and that cut down on whatever else you needed to take into space. The net result was NASA came up with the concept of the space shuttle. The space shuttle uses rocket engines to get into space. There are 3 engines on the space shuttle alone. If you walk around the back of it, you can see what looks like the bellows of 3 engines on the back of it. NASA didn't give us the engines. They're still using them in technology concept. So what you're looking at are the exhaust bellows from the space shuttle's engine. But it still, those 3 engines still wouldn't get the space shuttle into space with a full payload. And so we had to use solid rocket boosters attached to the fuel tank for the space shuttle. The space shuttle had 2 accidents, one in 1986 and one again in 2003. And it really caused us to have second thoughts about, well, do people always have to be involved with getting things into space? And the answer was, no, that's probably not necessary. You don't always need a truck if you need to get into space. Well, what was we were going to do in space? We wanted to build a space station. So we used the space shuttle, all 3 space shuttles, to take up the pieces that became what is now in space the International Space Station. Well, the International Space Station got built, And in 2011, we didn't need a truck anymore. And the truck was becoming very expensive just to take people into space, and NASA retired the Space Shuttle. That's how we got Discovery here in 2012. That's how Endeavour got out to California, and Atlantis is down in Florida. If you want to go see those space, because now we just need a small vehicle to get people into space. But NASA didn't have one. So NASA now buys seats in the Russian spacecraft to go up to the International Space Station. Later this year or early next year, an American version of carrying people into space may or may not be launched. It may take a little longer than that. Generally, good engineers are always optimistic, and optimism carries you to build a schedule that you sometimes can't always meet. So, but you want good engineers to be optimistic. This is the Space Shuttle Discovery that went into space 39 times. It did things like it took the Hubble telescope into space in 1990. The Hubble telescope was taken into space in 1990 with an expected lifespan of about 10 years. Well, when we got it into space, it didn't work right. The analysis of how we had built the Hubble telescope was we had actually ground the mirror in the telescope improperly, but perfectly improperly, and we were able to go back up and put eyeglasses on the Hubble telescope, and so it's still working. In fact, we've gone up and upgraded the Hubble telescope 3 more times since repairing it, to the extent that the Hubble telescope is still working today, 28 years after it was put into space, when it was designed to last 10 years. So some things can be made to work even longer. This is Space Shuttle Discovery. It was designed to be taken by rockets into space and then come back to Earth and land like a glider. Now, gliding is my definition versus yours may be different, but it does come in and land using the flow of air over the wings and the fuselage to slow down enough that it can glide to a landing down in Florida. But it only got one shot at that. If it missed the runway, it was toast. We never had that problem. We did have to land it at some other places occasionally. We landed it in California several times. We landed it in New Mexico one time. But the basic design of the airplane was to land it in Florida. Now, to go into space, it means you have to overcome gravity pulling you back. Technically, if I jump up, gravity immediately pulls me back down. Even though I have a mass, it is so infinitesimal compared to the Earth's mass that there's no chance of me jumping into space. But if you get going fast enough, you can overcome gravity's capability of immediately pulling you back to Earth. That happens to be going in an easterly direction from Florida, about 17,000 miles an hour. And what that means is that you go into what becomes an orbit around the Earth because you are overcoming gravity as you travel around the spinning Earth. To get back to Earth, however, all you have to do is slow down a few hundred miles an hour and gravity will pull you back to Earth. So the way we've always done in space is we have some special rockets attached to the spacecraft. The shuttle has them. If you walk around to the back of it, you can see some rockets sticking out back there. We turn the space shuttle around so that the rear end of it is going forward, and you fire those rockets. And if you slow the spacecraft down about 300 or 400 miles an hour, gravity will pull you back to Earth within half a revolution of the Earth. The problem is when you begin to come back through the atmosphere in any spacecraft, including the Space Shuttle, and you're still traveling at 15 or 16,000 miles an hour, when you begin to rub through the atmosphere, you build up what's called friction heat. In fact, the friction heat coming through the atmosphere at about 15,000 miles an hour builds up temperatures that can approach 3,000 degrees Fahrenheit. Early on in the space program, we protected the spacecraft by putting material on the bottom of it that burned up as you were coming back through the atmosphere. We had a heat shield that disintegrated as it burned up coming through the atmosphere. But that meant you could only use it once. The goal back in the 1970s was to build something that could be used over and over again. So instead of using an ablative heat shield on the space shuttle, we decided to use ceramics. Ceramic materials on the nose, on the underside, on the sides of it, on the tail. Everything was covered with special material that could resist high temperatures. Well, it turns out the nose of the space shuttle and the leading edge of the wings get the hottest. And so the material that we ended up coming up with for them is a material called reinforced carbon-carbon fiber. It's like a heat shield, except that it doesn't disintegrate at all. It reflects 3,000 degrees temperature. We put ceramic material all over the rest of the spacecraft. Early on, we built it in order to maintain the dynamics of the shape of the airplane as it penetrates the atmosphere. We built it in small pieces that we could make conform to the curves that are required for an airplane to be able to glide or land in a gliding fashion. After a certain period of time, we began to realize that, well, it gets real hot on the bottom, so we have these special ceramic tiles underneath and a few other places on the spacecraft. And then where it doesn't get quite that hot, we use white finish tiles. And then other places, we take ceramics and make them into woven material. So on the sides of it, you can see panels of material that resist those high temperatures. But it does get hot. When the space shuttle would land on the runway there in Florida, nobody would go up and touch the side of it when it first landed, because it was still hot from the high temperatures that it resisted as it came back through the atmosphere. This is the Space Shuttle Discovery that went into space 39 times and did more things, taking the Hubble telescope into space, taking pieces of the International Space Station into space, taking astronauts into space. Does anybody have any questions about the Space Shuttle? This